everyone! Welcome back to our channel. I am Teacher Jasmine.
And I am Teacher Julie.
And we are Best Friends! So for today, everyone, we will be dealing with another lesson. What will be our lesson for today?
It's all about geometric sequence.
Okay, go ahead.
And
she's not feeling well.
Yeah, but I will be doing our best for you.
Yes.
So I want you to listen carefully on our next topic for this week.
Okay, so go ahead. Are you ready?
Are you ready? Thank you also, thank you before anything else for our 200 subscribers. Thank you so much.
Thank you. Thank you so much.
I'm so fat, Best.
Same here.
No, you're not fat.
You're
We're
good.
best friends.
Yeah.
And I'm fat and you're thin.
Oh, don't say that.
How sexy are you?
Yeah. Hi. Okay. Shall we do it?
Yes.
Okay, let's begin.
What we're going to do right now is we are going to talk about geometric sequence and how do we define geometric sequence. So before we define geometric sequence, I will be giving to you the examples of geometric sequence. So let's start with number 1. 5, 20, 80, 320, so on and so forth. Example number 2, we have -2, -4, -8, -16, so on and so forth. Another example for a geometric sequence, we have 5, -15, 45, -135, so on and so forth. And number 4, we have 120, 60, 30, 15, so on and so forth. So these are the examples of a geometric sequence. So what have you noticed with our given sequence? We'll start with number 1. We have 5 as our first term, 20 as our second term, 80 as our third term, and 320 as our fourth term. What have you noticed with example 1, example number 2, example number 3, and example number 4? Very good, you got it right. We'll start with number 1. If you are going to notice, we just multiply our first term by 4. 5 times 4, we get 20. The same also, we also multiplied our second term by 4. So 20 times 4 will give us 80. The same also, multiply that one by 4, we get our answer, which is 320. Very good. Our number 1, we just multiply it by 4 to obtain the next term. Is that the same with number 2? Absolutely. For our number 2, if you're going to notice, we just multiply it by 2. Do you agree? Yes. -2 times 2 will give you -4. -4 times 2 will give you -8. And -8 times 2 will give you -16, so on and so forth. So if I will be asking for the next term for our number 2, that will be, if we will be multiplying this one again by 2, so if I will be asking for the next term, that will be, yes, that's -32. Did you get that? How about number 3? The same pattern that we had in number 1 and in number 2, what have you observed with our first term to obtain our second term? Absolutely. We just multiply it by -3. Are you following? So if we multiply 5 times -3, that will give us -15. And -15 multiplied again by -3, that will also give us, multiplied by -3, 5 times -3, that will give us +45. The rule of multiplication, negative times negative will give us positive. The same, our third term multiplied by -3, still the same, 45 times -3, we'll get our answer -135. Last but not the least, is that root of number 4? Let's see. This is 120. What did we do with 120 to obtain 60? Absolutely. We multiply that one by 1/2. 120 times 1/2, or in shortcut, that will become 120 divided by 2. That will give us an answer of 60. 60, the same, multiplied by 1/2, is still 30. And 30 multiplied by 1/2, that is 15. So in that particular examples, we have 1, 2, 3, and 4. They have a common thing that we did. And what is that? Yes. So if I will be asking for how do you define geometric sequence? A geometric sequence is a sequence whose next term after the first is obtained by multiplying a common number, or what we call a common ratio. Why do we call this one a ratio? Yes, we have number 1, our ratio is 4. For example, number 2, our ratio is 2. For example, number 3, our ratio is -3. And for number 4, the ratio is 1/2. Take note, a geometric sequence is a sequence whose next term after the first is obtained by multiplying a common number, or what we call a common ratio, where R stands for our ratio. How are we going to get the ratio if it's hard? Mom, it's so hard to find a common ratio. We don't know the number we multiply to obtain the next term. Very easy. How to get the ratio? You just divide our second term by its first term. Or you can divide our third term by our second term. Or you can have fourth term divided by our third term, and so on and so forth. If the answers here are the same, then they have what we called a common ratio. Take note, we just divide. So if number 1, if we are following our formula and it's hard for us to get that one, we'll just use our formula in getting the ratio. We'll have second term minus first term. Of course, our second term in number 1 is 20 divided by our first term, which is 5. So what is 20 divides 5? Absolutely, that's equal to 4. We're going to get the same. We'll have the third term divided by the second term. Our third term is, yes, it's 80 divided by our second term, which is, yes, it's 20. So 80 divided by 20, we get our answer, which is, yes, it's 4. So therefore, they have a common ratio. So that's why we call number 1 as a geometric sequence. The same also with number 2, number 3, and number 4. Do you get that?
Yes.
Okay, absolutely. So that's a geometric sequence. Different from arithmetic. From arithmetic, we have the same number being added to obtain the next term. But in geometric, the same number we multiplied times we multiplied to obtain the next term. So, if you are going to ask for this kind of problem, you are given first term, second term, third term, and then you are asked for the 7th term, or the 8th term, or the 20th term. This is the formula we are going to use, and you have to memorize that one. So we have last term equals first term times R, or the ratio, raised to the power of n minus 1. Don't forget, AN stands for the last term. That's your last term. A1, always remember, that's your first term. And N will stand for your number of terms. So with this formula, we can solve this kind of problem. Yes, I know we can use the skip counting 3 times 3 times 3 times 3, but it will take you a very long time. But with this formula, we can get the answer directly. So find the 7th term. So we'll have example number 1. Find the 7th term of the geometric sequence. 3, 9, 27, so on and so forth. Yes, we have to identify all our given first. So take note, we have to identify our givens. What are our given? We'll get our last term, AN. Do we have last term? Of course not, because we have to look for our last term. Do we have A1 or the first term? Yes, and that is 3, absolutely. Do we have a common ratio? Yes. How are we going to get the common ratio? We have succeeding terms. All you have to do, you just get the second term divided by the first term. So our second term here is 9. Divide it by our first term, which is 3. So we get 9 divides 3. Final answer, we get 3 as our common ratio. Next one, do we have n? N refers to the number of terms. Do we have n? Yes. We are going to look for the 7th term of the geometric sequence, or n is 7. So since all of these are present, we can now use our formula a sub n equals a sub 1 times r raised to the power of n minus 1. After having the formula, substitute a sub n. We don't know a sub n, or we don't know the last term. We are going to look for the a sub 7 equals, our first term is, of course, it's 3 multiplied by the common ratio, which is 3 raised to the power of n minus 1, or n is 7 minus 1. That's it. Next, copy our a sub 7 or 7th term. The same process that we did, we are going to simplify those who are inside the parentheses. So we'll just copy 3 and then simplify this one. So this will become 3 raised to the power of 6. After that one, a sub 7 or the 7th term, simplify those inside this parentheses or exponential first. So we copy first our 3 here. So 3 raised to the power of 6. You can use your calculator. So the answer is equals to, yes, that's 729. And then, for final answer, we multiplied 3 times 729. The final answer, we get our answer 2,187. So that's it. 2,187 is our 7th term of our given sequence, 3, 9, 27, so on and so forth. So what about if we are given this kind of problem? How are we going to solve this one? So example number 2. What is the ratio of the given geometric sequence if the first term is 3 and whose 12th term is 531,441? Yes. As always, you have to identify our given. So what are given? Our given are, so we have, do we have a first term? Absolutely. First term is 3. So our given, we have first term is 3. Do we have an or last term? Yes, we have here. And whose 12th term is 531,441. So our last term is 531,441. Next, do we have a ratio? A ratio, we can get that one if they do have succeeding terms. Do we have succeeding terms here? We don't have. That's why the common ratio is unknown. Do we have n number of terms? Absolutely. 12th term is our number of terms because that's equivalent to our last term. So n is equals to 12. With this given, we can now apply our formula. Our formula is a sub n equals a sub 1 times r raised to the power of n minus 1. As always, substitute all that are present in here. So a sub n, do we have a sub n or last term? Yes, we have 531,441 equals. First term, do we have first term? Yes, and that is 3 times, we'll put parentheses so we can separate if there are negative sign. R, do we have R? R is unknown, so we just copy R raised to the power of n minus 1. Our n is 12, so this will become 12 minus 1. The same step, after we're done substituting, then we have to simplify. So simplify first those inside the parentheses. So the rest will be copied. So we'll have 531,441 equals 3, open and close parentheses. Simplify the exponents. We'll have r raised to the power of 12 minus 1. We have, yes, we have 11. Since if you are going to look at this one, our unknown variable is r. So we have to solve for r. So there should be no numerical coefficients of r. If you're going to notice, we have 3. So how are we going to eliminate 3? We are going to use the division property of equality, wherein we divide both sides by 3. So this 1 here will be eliminated because that will become 1. 3 divides 3 is 1. So what's left here is only r raised to the power of 11. 531,441 divided by 3. You can use your calculators. The answer is, yes, 177,147. I hope we have the same answer. So we have here, is equals to r raised to the power of 11. Since we have to solve for r alone and not r raised to the power of 11, we have to simplify this radical sign. So how do we do it? We are going to use the extracting of roots. How do we extract our roots? If this is raised to the power of 11, then we are going to have the 11th root of r raised to the power of 11. That makes that one equal only to r. So if we use this one, the 11th root of r raised to 11, the other side also will have, we will also get the 11th root of 177,147. So this will become simplifying. This will be automatically become r. That's our ratio. And how do we use this one? Yes, you have your calculator, or you are going to look for a number multiplied by itself 11 times. That will give you the answer of 177,147. And that is equal to, yes, the 11th root of 177,147 is 3. 3 multiplied by itself 11 times, this is the answer that will come out. So our common ratio is equals to 3. So, how do we solve this kind of problem? Yes, our first step, we have to identify all the given. So, you have to identify first the given and what is being unknown. After that one, second step, you are now going to use our formula and then substitute what are the given. So, next step, you are going to simplify and solve for the unknown variable. So that's how we solve this kind of problem in geometric sequence. Thank you. I hope you learned our topic for this day about geometric sequence. Don't forget, if you have questions or clarifications, just type in or in our chat box down. And don't forget to subscribe. Thank you.